Chapter number 11. Okay, in the beginning, first of all, light is possessing the wave nature, and it can be said from the Maxwell's equation for electromagnetic wave. We have completed the chapter, and from those equations which were given by Maxwell, okay, and from the Hertz experiment which is discussed in that particular chapter, electromagnetic wave, okay, we can say that the light possess the wave nature. Okay, so light is having the wave nature, this we all know. Now, before beginning this chapter, in the modern physics, there were certain observations of various experiments which suggest that light rays are stream, that is flow of negatively charged particle. Now this is observed from different observations. They are like this. Okay, in 1895 Röntgen invented X-ray. Then in 1897 J.J. Thomson invented electron, which was landmark to study the structure of atom. Then in 1870 William Crookes invented cathode rays. He filled gas in discharge tube. He applied electric field to the electrode at both the ends of the tube. He observed that electric charge is produced which travel to other end, and when incident on fluorescent material, it produces small flickering of yellowish color. From this, he concluded that cathode rays are made up of stream of negative charged particles. Then J.J. Thomson first measured the speed of cathode rays, which was observed or order of 1 by 20 to 1 by 30 times the speed of light, that is 3 into 10 raised to 8 meter per second. He also obtained the specific charge, that is ratio of charge and mass of electron, which was found to be 1.76 into 10 to the power 11 coulomb per kg. And J.J. Thomson suggested that specific charge, that is E upon m, does not depend on type of gas filled in the cathode ray tube, and also does not depend on metals used as electrode. So these were different observations, okay, and various experiments which are suggesting that light rays are the stream, that is flow of negatively charged particles. Now there is some information about negative electric charge which is emitted from metals when ultraviolet light is incident on them or metals are heated. Okay, in 1887 it was observed that when ultraviolet light is incident on metal or when some metals are heated, negative charge is emitted from them. So whenever the metal is heated or UV light is incident, negative charge is coming out. Particles produced by different methods have similar nature. In 1897, J.J. Thomson called it as electron and showed that electron in fundamental and universal particle. Electron is a fundamental and universal particle. Okay. For invention of electron, J.J. Thomson was given the Nobel Prize, okay, in 1906. In 1913, American scientist Millikan measured charge of electron by oil drop experiment. He observed that charge on any oil drop is in integral multiple of fundamental charge, that is 1.6 into 10 to the power minus 19 coulomb, and as you know that Q is equal to Ne. Thus, from specific charge E upon m, mass of electron can also be obtained. Now we talk about the emission of electron from metal. We will define work function. Okay, we will write the unit of work function, okay, and it depends on the type of metal, okay. Normally electron cannot escape from the surface of metal that we know, okay. Metals on its own does not allow the electron to go out from its surface. When temperature of metal is increased, kinetic energy due to oscillation also increases. When this energy excess or exceeds the binding energy, then the electron will escape from the metal surface and it will become positively charged, or we can say metal will become positively charged as electron is lost. But due to attractive force between positive ion and negative ion, electron again is attracted to metal surface. If energy of electron is more than the energy due to attractive force, then what will happen? This electron is going to escape from the metal surface. So you have to supply the energy from outside which is more than the binding energy. So minimum energy which is required to make an electron escape from the metal surface is nothing but work function of the metal, okay, and work function of the metal is denoted by phi 0 and its unit is generally electron volt, okay, and this work function depends on the type of metal and the surface of the metal. Now, what is the unit of energy in atomic and nuclear physics and in what we call it? In atomic and nuclear physics, the energy is measured in terms of electron volt. Okay, so electron volt is the unit, and 1 electron volt is nothing but when 1 electron is accelerated under the potential difference of 1 volt, the energy which is acquired by it is called the electron volt. So when you have 1 electron which is accelerated under the potential difference of 1 volt, whatever energy it has acquired is called 1 electron volt, and 1 electron volt is nothing but 1.602 into 10 raised to minus 19 joule, okay, and 1 joule is nothing but 6.242 into 10 raised to 18 electron volt. Now these are the different work functions of different material or metal, okay. Cesium is having 2.14 electron volt, okay. Similarly, say nickel is having 5.15 electron volt. This way different metal is having different work functions. Now there are different methods to obtain the emission of electron from the metal, okay. The first method is thermionic emission. When metals are heated, current is passed through the filament of metal, say for example, then what will happen? Filament will become hot. So metal is heated by some means. Electrons are given sufficient heat, that is thermal energy is obtained by the electrons. Then what will happen? Electron will escape from the metal, and such an emission is called the thermionic emission. There are examples: diode, triode, TV tube, okay. Electrons are emitted by using this thermionic emission method. Then there is a field emission, okay. Field emission means whenever the metal surface is applied the electric field of the order of 10 to the power 8 volt per meter, electrons are emitted from the metal, and such an emission is called the field emission, okay. And the emission which we are going to discuss in this particular chapter, the whole chapter is depending upon this, that is photoelectric emission. When on a clean metal surface, okay, incident, or we can say a clean metal surface is radiated a proper frequency electron, Okay, rather proper frequency radiation is incident rather. Okay, proper frequency radiation is incident on a clean metal surface, then what will happen? Electrons are emitted from the surface. So we can say that when on a clean metal surface which is incident a radiation of proper frequency, say for example you have a clean metal surface and proper frequency radiation is incident on this clean metal surface, then electrons are ejected out or emitted out from the surface, and this kind of emission is called the photoelectric emission. Okay, electrons emitted by this method are called the photoelectrons. They are known as photoelectrons. Now there are Hertz observations. Photoelectric effect was first observed by this scientist, that is Hertz. Okay, Hertz made experimental investigation of production of electromagnetic waves by means of spark discharge that we have discussed in the previous chapter. Okay, Hertz observed that high voltage spark across detector loop were enhanced when the emitter plate was illuminated by ultraviolet light from the arc lamp. When light is incident on metal surface, some electrons near metal surface, some electron near the surface absorb enough energy from the incident radiation to overcome the attractive force or attraction of positive ions in the metal surface. So, a metal surface which was irradiated by the ultraviolet light from the arc lamp, UV light from the arc lamp, what would have happened? This plate must have emitted electrons. So this plate becomes positive. This plate becomes positive. Okay, and this was observed by scientist Hertz. Okay, so whenever a high voltage spark across detector loop were enhanced when the emitter plate was illuminated by ultraviolet light from the arc lamp. Okay, when light is incident on metal surface, so whenever this ultraviolet light is incident, what had happened? The electrons have come out or electrons have been ejected from this metal surface, and this metal surface has become positively charged. Okay, and this was observed by this scientist Hertz. Again, gaining sufficient energy from incident light, the electrons escape from the surface of the metal into surrounding space. This was the observation of this scientist, that when the metal surface was incident by the ultraviolet light from the arc lamp, then electrons were ejected and this metal surface became positively charged. Okay, and the electromagnetic wave which was reaching here, which were been produced in this Hertz experiment, were showing a kind of different behavior. Okay, and this different behavior made this scientist Hertz to find that why this different behavior is seen, that of electromagnetic waves which are reaching here on this plate, that is a receiver plate. Then he observed that whenever the ultraviolet light is falling on this metal plate which is there on the receiver side, was losing the electron. Okay, and because of that the wave which was reaching here was showing a kind of unusual behavior, which led him to conclude that whenever ultraviolet light is incident on this metal surface, And if you have this ultraviolet light of proper frequency, okay, proper frequency, then the electrons are emitted. Okay, that was his observation. Okay, thank you very much. Try to watch this 2-3 times and understand, read the lesson properly. You will get the idea about this particular topic. Okay, thank you very much.